Today we are going to find the volume of prisms and cylinders, and we're going to do those two together because their formulas are extremely similar. So volume, just as a definition, typed up for you here, it says the volume of a solid is the number of cubic units contained in its interior, and then volume is measured always in cubic units because we're in 3 dimensions. So another thing volume might be referred to as capacity, like how much can something hold. Just a little example here with some post-it notes. So if you think about a stack of post-it notes, we would take the areas of all the post-it notes in the stack and add them all up, and that would give us the volume. So the base would be the shape of your post-it note, and then the number of post-it notes here that we'd have to add all the way up would match up with the height. So that's going to talk about that in the formula here in 1 second. And sometimes the shape could move to the side a little bit. Here's another example down here, a little bit more, not so much with a post-it note, but a prism that is kind of slanted a little bit. So that can happen too. The height is the distance between the bases always. So this is just right straight up. This is angled a little bit. So the height is always the distance between the two bases that are vertical. And here's just a little example up here, a little picture for you guys to see the cross section, to see that these match the bases. So this prism here is square, or I'm sorry, it's rectangular because it's 3 by 2, but I see all these are 90-degree angles, so this is the same all the way up. This is 3 by 2, this would be a parallelogram, but it would still be a prism, and then this is a triangular prism here with the base being a triangle. So how to find the volume of any prism is capital B for area of the base times the height. So B, capital letter, area of the base, and that formula could change depending on the type of base you have. So for example, if we have a rectangular base, the area of a rectangle, just base times height. If we have a triangular base, then that formula would change because it would be 1/2 base times height. So you have to be mindful of what your base is. And then the h is the height, and in a prism it's the distance between the two bases, and it's got to go at a 90-degree angle like you see here. So straight up and down, this has to go at a 90-degree angle so it comes outside of the shape if it's kind of slanted like that. Okay, so we're just going to do a couple examples together, a couple different kinds. Try to keep the formula on the screen so you guys can see it. And I'm going to grab a highlighter really quick. Now remember, if you are using a rectangular prism, the top and the bottom could be the base, the left and the right could be the base, or the front and the back can be the base. What I'm going to do here is I'm going to just go ahead and use kind of what I see as the bottom as my base. Now any other type of prism, when you have the base, it's got to be 2 parallel faces. So like when we come over here, the base has to be the triangle because the only 2 parallel faces are these 2 triangles. So the rectangular prism is kind of a special case. When you're doing volume or surface area, they have to give you the base so you can figure it out. But any other prism, it's going to be the shape of the base has got to be parallel. Okay, so here, area of my base is just going to be base times height, length times width, however you want to do that. So 24 times 20. And then the height is going to be the distance between the 2 bases. So the bottom of this box and the top of this box, distance between them is 10. So literally all I'm going to do on my calculator, area of the base, we've got 24 times 20, and then we're going to multiply that by 10. So this is 480. That was 3 dimensions. I multiplied length, width, and height. And so when you do your label here, since we did 3 dimensions, it's going to be units cubed or cubic units. So you could call that centimeters cubed, cubic centimeters, or you could just abbreviate centimeters and then put a little 3rd power. Okay, now here The area of the base is going to be the area of this triangle, and the height is the distance between the two bases, so that's just the 40. Now, the issue with this question here, the 29 would match up here on the triangle. But if I want to find the area of the triangle, I need the base and the height of the triangle. So just for the triangle, I'm going to put a little X there. I need that distance. So the base is the 20 of the triangle, the height would be the X, so we got to figure that out. Because this is a right triangle, I'm just going to use the Pythagorean theorem. So the X and the 20 would be the legs. And so I'm just going to set up the Pythagorean theorem. The 29's got to be the hypotenuse. It's always across from the right angle. So I'm just going to grab my calculator here. And remember, you guys can do all these on a scientific. I'm just using my graphing calculator because it shows up a little better on the screen. So I'm going to take the 29 squared and subtract the 20 squared. So x squared is going to be 441. And I'm going to go ahead and try to take the square root and see if I get a nice number. And I do. And if you don't, just go ahead and, like, let's say this wasn't a nice number, you could just plug it in as the square root of 441, for example, if it wasn't a nice number. In this case, I've got a perfect square. So area of the base, that triangular base, is 1/2. The base of just that triangle would be 20. The height of the triangle, that's what we had to figure out. That ended up being a nice number. That was 21. So if I didn't get a nice number, like I said, you could just plug that in as square root of 441 if you want to while you're doing the problem. It's totally up to you. So volume, area of the base, and then the height. So we're just going to plug that all in. So 1/2 times 20 times 21 times 40, and I got 8,400. This is going to be meters cubed. Okay, volume of a cylinder is really just a special case of a similar formula to the prism. It's still area of the base times the height, but whenever you have a cylinder, the base is always circular. So instead of putting in area of the base here, I always have a circle if I'm working with a cylinder. So circle area is pi r squared times the height. And again, the height runs between the two circular bases. If it's slanted a little bit, it has to come at a 90-degree angle. You need two things to calculate this. You need the radius and you need the height. So I'm going to show you two ways to do these in terms of pi and then to the nearest tenth. So volume here, this is just pi times my radius, which is 3 squared times 8. Okay. Let's say the question said we're going to leave it in terms of pi, so let's just do that first. So I'm just going to go ahead and do 3 squared times 8. That's 72. So in terms of pi, this would be 72 pi, still centimeters cubed because we're working in 3 dimensions. We're doing the area of the base, which is 2 dimensions, and then the height. And then let's say the question said, hey, we're going to round to the nearest tenth. Then you go ahead and just take the 72 times your pi button, and let's say they said nearest tenth. Here I would say 226.2. That 9's going to round that 1 up. So just so you guys can see both ways to do that. Still centimeters cubed. Same problem. The only thing I wanted to point out differently here is just be mindful, do they give you the radius or do they give you the diameter? Because the formula is going to require the radius. Here they're telling you the diameter is 16, so the radius would be 8. The height, the distance between the two circular bases, is the 9. So for volume, I do pi times 8 squared times 9. So I'm going to do 8 squared times 9. This is 576 pi. So if that's what, in terms of pi, go ahead and write the 576 pi. If they wanted to have it to the nearest tenth, this would be, let's see, 1,809.6 cubic feet. So it's important to be able to write it in both formats. When you write it in terms of pi, that's considered an exact answer because we're not rounding anything. And then when we write the volume, rounded to the nearest tenth or hundredth or whatever the question asks you, that's an estimated answer. It's really close, but it's not an exact answer. So both are useful, and both are asked on the homework assignment. And my next example is 2 work backward problems. So this says the volume, so I'm going to give you the volume of a rectangular prism is 840 cubic centimeters. If the area of the base of the prism is 56 centimeters squared, find the height of the prism. So here's your volume formula. They give me the volume, and they give me the area of the base is 56, so I'm just going to plug that in for B. And then we want to find the height. So all you're going to do on your calculator is just grab 840 and divide that by 56, and so the height would be 15. And that's all you have to do. Now, since we are talking about, in case you have to label that, a height is just a single dimension, so it would just be labeled with plain units, in this case centimeters. All right, now this one gives me volume of a cylinder, so I'm just going to write the formula there. I know the volume, so I'm going to sub that in for B, that 3,312 pi. Okay, pi is part of the formula. It says if the height of the cylinder is 23, what's the radius? So I don't know the radius here, but I do know the height is 23. Okay, first thing I would do with this, everything on both sides is being multiplied. So I'm actually going to divide both sides by pi just real quick, and it ends up canceling out on both sides when they leave your volume in terms of pi here. So this is going to end up being 23 times my radius squared. So what I want to do here, divide by 23. And I'm going to grab my calculator real quick. So 3,312 divided by 23. Get 144. It's my radius squared, so I got to take the square root there. And since we're talking about a shape, we don't want to put the plus and minus symbol because you can't have a negative radius. But right there, your square root of 144 would be 12. And then again, this is a single dimension, just the radius. It's just going to be plain units. In this case, it's going to be inches. Okay. And I have 2 more examples, and these are called composite space figures. So these don't necessarily have a specific formula. You got to kind of look at the figure and see what you have in terms of the shape. So we're going to find the volume here. So I would argue this is a curved, like a half circle here. So the top of this is half of a cylinder, and then the bottom of this is just going to be a rectangular prism. So here's what I'm going to do. I'm going to have the prism, the volume, plus I have half a cylinder. Okay, for the prism, area of the base times the height, and for the cylinder, pi r squared times the height, but we'll do half of that because we just have half of a cylinder. Now, the area of the base, remember, for the rectangular prism, you can use any of the faces as the base. I am going to go ahead and use the bottom. And so the area of my base there, I'm going to say, is 6 times 7, which is 42. And then the height, the distance between, here would be my other base. Distance between those is going to be 8. So for the volume of that prism, I'm just going to do 42 times 8. I'm just going to grab that on my calculator real quick. And it's going to be 336. Now, for the prism, this is a little tricky. Let me grab a different color. So if you guys are looking at the picture there, this 6, like this is 6, so this would also be 6. Now, that is also going to match up with the diameter of that half cylinder, if you will. So I've got a half of a cylinder there. That's going to be my diameter, which is 6. So that means my radius is 3. Okay, now in terms of the cylinder here that we have, this is tricky. So this half circle here would be my base. So the distance between those two half circular bases is the 7. So that's important. So here I'm going to have 1/2 pi. My radius is going to be 3, and then the height here between the two half circular bases is going to be 7. So just pay attention when you're working through that. So I'm going to go ahead and write that in terms of pi really quick. So I'm going to do 1/2 times 3 squared times 7. And so here I'm getting 31.5 times pi. And then the question says we went around the total volume to the nearest tenth. So I'm actually going to just go ahead and add those together. So 336 plus, and I'll just put this in parentheses, 31.5, whoops, sorry about that, times my pi button. And to the nearest, okay, so the 6 here would round the 9 up actually to a 0. So to the nearest tenth there, we got to actually go 435.0, or you could just put 435, and then this is going to be inches cubed. And I have one last problem here. This is a cube, and I know that because the length, the width, and the height are all the same number. So I have a cube here, and then its intention for this problem is there's a hole through the middle, and we want to find the volume. Okay, so let me find, I just have a cube, which would be same formula for a prism, and I want to subtract out of the middle. It's a full cylinder. We're going to go ahead and assume it goes straight down, kind of cuts a cylindrical shape out of the center of that figure. So we're going to subtract here. Prism, area of the base times height, cylinder, full cylinder, so I don't have a half in front of this, pi r squared times the height. Okay, area of the base is just going to be 10 times 10, and then the height is also going to be 10. So this, if you multiply it out, is going to give you 1,000. Now, the radius here, they're giving you the diameter of the cylinder as being 8. This is not really drawn to scale very well. So the radius is going to be 4. And then the height would be the distance between the two circular bases. So it's going to match the height of the prism here, which is going to be 10. So I'm just going to leave this in terms of pi really quick. 4 squared is 16. Times 10, this would be 160 pi. Since we have that hole going down the middle, that's why I'm going to go ahead and subtract this. And so I'm just going to grab my calculator for that calculation and do 1,000. That'd be the area of the prism, minus 160 and times pi. That would be subtracting out the cylindrical hole down the middle. And to the nearest tenth, this is going to be 3 followed by a 4, so that would not round that up, so I'm going to do 497.3, and this is going to be cubic inches.